Chapter 8.2, Arithmetic Sequences and Series. An arithmetic sequence is a list of numbers that have addition or subtraction as a pattern. So we'd add or subtract to go from one term to the next. The addition or subtraction pattern is called the common difference. So example 1, we want to identify if the list is arithmetic. If it is, then we'll write down what the common difference is. So for A, we start with -9. To get to the next value, so -9 plus 7 would be -2. -2 plus 7 is 5. 5 plus 7 is 12, and 12 plus 7 is 19. So we have a pattern. We're adding the same value each time. So yes, this is arithmetic. And our common difference, D, is 7. For B, say 17 take away 3 is 14. Take away 3 is 11. Take away 3 more is 8. Take away 3 more is 5. So yes, this is arithmetic. And our common difference is -3. All right, last example. So 24 to 12. It's like we would take away 12. 12 to 6. Looks like we would only take away 6. We could keep going, but this is enough for us to stop. If the difference is not the same each time, it is not arithmetic. Here we have a rule for the nth term of an arithmetic sequence. There's going to be a couple different ways we use this. One way would be to find an nth term, or find any term in a given sequence. So let's talk about each piece, and then we'll talk about some of the parts together. So a sub n, that represents the nth term in the sequence. Now that n could be anything. We could choose an n, so if we wanted to find a certain term. Sometimes you'll be given an n. So for example, a sub 1 represents the first term. N is the term number. D, again, is the common difference. So using A as an example, so -9 is our first term. So that would be a sub 1. Our second term, a sub 2. Third term, a sub 3. Now, again, one way we would use this is to find a term. So we could find the second term, we could find the 8th term, we could find the 500th term. So quick example, let's go ahead and use it to find our second term. So we already know what it is. We're just going to do this to see how it works. So if I want to find a sub 2. Well, I need to know what my first term is, a sub 1. Well, a sub 1 is minus 9. Then I'm going to add n minus 1. In this case, my n is 2 times the common difference. And our common difference was 7. So a sub 2, we find that by taking our first term and then adding, so 2 minus 1 is 1. So we end up adding our common difference one time. And that should make sense, because to go from your first term to your second term, you add your common difference once. If we wanted to get our third term, we would have to add our common difference a second time. So that's what that n minus 1 times d represents. This is the number of times you need to add your common difference to your first term. Will get you to the term you want to find. All right, so let's do a different type of example. So if we look at number 2, it says write a rule, which means another way to say it is an equation, for the nth term of the arithmetic sequence and find a sub 15. So we want to write a general rule for any term, and then we want to find the 15th term. So let's start by writing down what we know so far. So we know a sub 1. A sub 1, remember, is just our first term, so that's 55. We can find our common difference. So from 55 to 47, looks like we'll take away 8. So in general, we can say a sub n, any term, is going to be equal to our first term, which is 55, plus the number of terms minus 1 times our common difference minus 8. As usual, we want to simplify as much as possible. So we'll distribute. Combine like terms. Be minus 8n plus 63. So this equation is specific to this sequence. This will tell us any term in this sequence. So if we want to find the 15th term, we would say, well, a sub 15 is equal to minus 8 times n. But we know what n is. We want the 15th term. That tells us n is 15. So that n here will be the same as that n there. So negative 8 times 15 plus 63 will get us a sub 15 is minus 57. So if we continued with our common difference, the 15th term would be negative 57. One thing different with the layout of the notes we're doing this time, the practice problems are not going to all be at the end of the notes. After we do an example, you will do a practice problem. So it's a good idea. It would be a good idea to pause, do the practice problem, and then you can start the notes for the next example. In example 3, we're going to write a rule again. But we're going to write a rule given some different information. So we don't know what the sequence is. We're given that a sub 19 is negative 45, and we're given the common difference is minus 3. So we want to write a rule for the nth term, and then after that, we will graph the first 6 terms. So important information, a sub 19 is negative 45, and again, the common difference, d, is minus 3. So our first step, we want to find our a sub 1. We need to know what our first term is. So we're going to go back to our equation for the nth term. Let's say a sub n is equal to a sub 1 plus n minus 1 times d. Now, we know something about the 19th term, so let's plug that in. Let's say a sub 19 is going to be equal to the first term plus, now a sub 19 tells us a couple things. It tells us that n is equal to 19. We also know our common difference is minus 3. Now a sub 19 also tells us that the 19th term is negative 45. So I can say a sub 19 is minus 45. And that's equal to the first term plus 19 minus 1 times minus 3. So again, a sub 19 is negative 45. So the 19th term is negative 45, and our n is 19. So now we can solve this for a sub 1. (18 times negative 3) minus 54. Add 54 to both sides, and we get a sub 1 is 9. Okay, we got our first term. Now that we have our first term, we have enough information to write our rule. So step 2, we're going to write our rule. And remember, saying write a rule, that's the same as saying write an equation. And we're writing an equation for the nth term. So again, we're going to start with our a sub n is equal to a sub 1 plus n minus 1 d. And we just want to plug in our first term, our common difference, and simplify. So our a sub 1 is 9 times n minus 1 times our common difference, which was minus 3. Distribute. So minus 3 times n is minus 3n. Minus 3 times minus 1 is plus 3. Combine like terms. So a sub n is equal to minus 3n plus 12. So if we know any term and the common difference, we can find an equation to describe the entire sequence. We just need to first find a sub 1, our first term, then we can use it to write a rule. All right, next we're going to graph the first 6 terms. So our first term, we already know our first term, that's a sub 1, that's 9. So our second term, we can plug in n is 2, or minus 3 times 2 plus 12, which is 6. And then we'll do the same for each. So we're just plugging it into n. All right, so let's graph this. Just so it's easier for you to see, I'm going to use a bigger graph. So this is going to be n, the number of terms, and then this will be the value of each term. So over 1, up 9, over 2, up 6, 3, 3, 4, 0, 5 minus 3, 6 minus 6. We can see our relationship is linear. This should make sense for a couple reasons. We have a common difference. So every time we increase a term, we either increase or decrease by the same amount. So in this case, our common difference was 9. And if we look at our equation again that describes our sequence, this is definitely a linear equation. Right? It has a y-intercept and a slope. And we can see our slope is -3. So that's why we are decreasing. Oh, and sorry, I misspoke earlier. Our common difference is not 9. 9 was our first term, our a sub 1. Our common difference was -3, which is also our slope. Okay, now would be a good time to pause and work on the next practice problem. Example 4, we're going to write another rule. And again, we're going to write a rule given a different set of information than we had for the other examples. So in example 4, we know what the 7th term is, and we know what the 26th term is. That's it. We don't know the first term, we don't know the common difference. So, given two terms, step 1, we're going to write a system of equations using our given terms. Or another way to say it is, we're going to write an equation for each term. So an equation for a sub 7, a separate equation for a sub 26. So for our 7th term, a sub 7 is going to be first term, which we don't know, plus n minus 1. Well, a sub 7 is our 7th term, so n is equal to 7 minus 1 times d, which we don't know our common difference. But again, we do know what a sub 7 is. A sub 7 is 17. So we can say 17 is equal to a sub 1 plus 7 minus 1, or 60. So we'll do the same thing for our 26th term. So a sub 26 is equal to a sub 1 plus, and again, n is 26. That's our 26th term. So 26 minus 1 times d. but we know what a sub 26 is. It's 93. So we can say 93 is equal to our first term plus 26 minus 1, or 25 times our common difference. Step 2, now that we have an equation for each term, we want to solve the system, which just means use the two equations to find D. So we need our two equations. So 17 equals a sub 1 plus 60, and 93 is equal to a sub 1 plus 25d. So a bit of review. It's been a while since we did systems of equations. We want to either add these together or subtract them to eliminate one of the variables so we can solve for the other. They both have an a sub 1. So I'm going to go ahead and multiply the top by minus 1. So left with minus 17 is equal to, I'm going to distribute, minus a sub 1 minus 6d. I'm not going to change the bottom at all. 93 is equal to a sub 1 plus 25d. And then I'm going to add these together. Minus 17 plus 93, 76. Minus a sub 1 plus a sub 1 is 0. Minus 6 plus 25 is 19. Divide both sides by 19, and we get, looks like D is 4, so our common difference is 4. Now that we have our common difference, we can use that to find our first term, our a sub 1. So step 3, find a sub 1 using your common difference. And just like systems of equations, once you find one of the variables, you take it, plug it back into one of the originals to find your other variable. So I'm going to plug my common difference into my equation for my 7th term. So I'll say 17 is equal to a sub 1 plus 6d. D is 4. So 17 is equal to a sub 1 plus 6 times 4. 6 times 4 is 24. We take away 24 from both sides. It looks like my a sub 1 is minus 7. Now that we have our a sub 1 and our common difference d, we can finally write our rule or our equation. So last step, step 4, we're going to write our rule. So a sub n, so our rule in general, is going to be equal to our first term, negative 7. plus n minus 1 times our common difference, 4. So distribute, combine like terms. So 4n minus 4, or a sub n is equal to 4n minus 11. Okay, you can pause to work on the practice problem. All right, next we're going to talk about arithmetic series. So an arithmetic series is the sum of the terms in an arithmetic sequence. So you might ask the question, well, the sum of how many terms? Well, that's something we can either decide, like we could add the first 3 terms, the first 8 terms, the first 100 terms, or it's something you will be asked to do. Like you'll be asked to add a certain number of terms together. Now, if there's only a few terms, it's easy enough to just add them. But if there's a lot of terms, it's a lot more difficult, or just it'll get very tedious. So we have a formula that makes it a little easier. So S sub n, this stands for the sum of n terms, will be equal to n times a sub 1 plus a sub n divided by 2. Or another way to say it is, the sum of n terms is equal to the number of terms times the first term plus the last term divided by 2. Right, let's do an example. Now, for our example, we're going to have a new notation. So this symbol here is sigma. Sigma is just a fancy way to say find the sum. And then we'll be given the number of terms, like from where in the sequence to how far. Right? So here it says from the first term to the 20th term. So we want to find the sum of the first 20 terms. We're also given the rule for a sub n. So here is the rule for the sequence. So we don't need to find the rule, it's given to us. Okay, let's use what we're given to find the sum of the first 20 terms for this sequence. So I'll write down in general again. So I want S sub n is going to be equal to n times a sub 1 plus a sub n divided by 2. So it's a few things we need to find. We know we want the first 20 terms. So that tells us n is going to be 20. We need a sub 1. So a sub 1 is going to be equal to, now, like we did with the graphing, once we have a rule for our sequence, we can just use the rule. So that's our rule. So a sub 1 is going to be equal to 3 times 1 plus 7. Similarly, we need to find a sub n, or a sub 20, because that's going to be our last term. So a sub 20 is going to be equal to 3 times 20 plus 7. So my a sub 1 is 10, and my a sub 20 is 67. So we have all our pieces. Now we just need to plug them in. So s sub 20, remember that just means the sum of the first 20 terms for our given sequence is equal to 20, so our n is 20, times our first term plus our 20th term, all divided by 2. Now here, we can do a little simplification before we multiply. I think like it's 20 over 1 times 77 over 2. We can reduce 20 over 2. 20 divided by 2 is 10. 2 divided by 2 is 1. So s sub 20 is going to be 77 times 10, or 770. So for this sequence, if we added the first 20 terms together, their sum would be 770. All right, now you can do the last practice problem.